Okay, here are your notes for Unit 3. We're starting Unit 3, and this is Section 4.3. I've drawn 3 number lines for you. And when you look at number lines, it's important to find out where 0 is, and I lined up the zeros. It's also important to find out where 1 is, and I lined up the 1s. 3 over 3, that's just 1. 6 over 6 is 1. 12 over 12 is 1. The first number line I split up into thirds, 1/3, 2/3, 3/3. The second number line I split up into sixths. And the third number line I split up into twelfths. And since everything's lined up, it helps me to show you equivalent fractions. So these 3 here are equivalent. They line right up. They all 3 actually equal the same amount. They look different, 1/3, 2/6, 4/12, but they're equal. Another pair of equivalent fractions, 5/6 and 10/12. 5/6, 10/12. They're equivalent. They equal the same amount. Okay, so let's write that down, what equivalent fractions are. Equivalent fractions, they represent the same value. Represent the same value. They might look different, but they're actually equivalent. Equivalent is very similar to equal. Equivalent, equal. Okay, your job for homework is going to be to come up with some equivalent fractions. So if you take 1/3 and you want to come up with something that's equivalent to 1/3, what you do is you just multiply the top and the bottom, the numerator and the denominator, by whatever you want, as long as it's the same on the top and the bottom. So I can multiply the top and the bottom by 2. When I do that, I just multiply straight across, and 1 times 2 equals 2, and 3 times 2 equals 6. 1/3 is equal or equivalent to 2/6. And all I did was multiply basically by 1, right? 2 over 2 is 1, and it's okay to multiply by 1. It doesn't change anything. I could multiply the top and the bottom by 5, so 5 over 5. What does 5 over 5 really equal? 1. What happens when you multiply by 1? Nothing really changes. It might look different, so I'm going to multiply across the top and the bottom. It's going to look different. I'm going to end up with 5/15. But it's actually equal. 1/3 is equal or equivalent to 5/15. Okay, another example, 6/7. I can multiply the top and the bottom by whatever I want. Let's multiply by 3 over 3, as long as I do the same thing on the top and the bottom. 3 over 3 is 1. I'm just drawing a big fat 1. Maybe I'd multiply instead of by 3 over 3, maybe I'm going to multiply by 10 over 10. 10 divided by 10 is 1. It's just a big fat 1. I multiply straight across, multiply numerator times numerator, denominator times denominator. On the first one I'll get 18 over 21. On the second one I get 60 over 70. And I've come up with equivalent fractions. 6/7 is equivalent to 18/21 and 60/70. And all I'm doing right in here, all I'm doing is using the identity property of multiplication. The identity property of multiplication, which tells me that I can multiply by 1 and it does not change anything. It looks different, but it doesn't change the actual value. So identity property of multiplication, you just multiply by 1. And it's okay. It's perfectly legal. Alright, so that's equivalent fractions. By the way, this represents the big fat number 1. Okay, simplifying fractions is the same thing as reducing. And when you simplify and reduce, you have to make sure that the numerator and denominator, the numerator and the denominator have no common factors. Have no common factors other than 1. 1 can go into any number. So no common factors except for 1. Alright, so the first example, 27 over 42, you have to ask yourself what divides equally into 27 that also will go into 42. Well, I know 27 can be divided by 3, so let's try that. So I'm going to divide the top by 3, which means I have to divide the bottom by 3. I have to do the same thing to the top and to the bottom. Oh, look. All I'm really dividing by is 1. There's a big fat 1. And 27 divided by 3 is 9. And 42 divided by 3 is 14. And then you ask yourself, can anything go into 9 that also goes into 14? And the answer is no. So this is reduced. And by the way, it's equivalent also. Even though I found it by dividing instead of multiplying, they're equivalent. But this right here is reduced. I can't divide the top and the bottom by anything else. Alright, next example, 72 over 100. They're both even, so I know I can divide both of them by 2. So I divide the top and the bottom by 2, and 2 over 2 is 1. It always has to be some form of 1. The top and the bottom you divide by the same thing. 72 divided by 2, 36. 100 divided by 2, 50. And you ask yourself again, what can go into 36 that can also go into 50? Well, you know what? They're both even, so I know I can divide both of them by 2. Notice whatever I do to the top, I have to do to the bottom, because I'm using 1. And then I just divide. 36 divided by 2, 50 divided by 2. 36 divided by 2 is 18. 50 divided by 2 is 25. What can go into 18 and into 25? Nothing. Well, 1, but that won't do me any good. So this is reduced. Nothing else can divide into 18 and into 25. And by the way, 18 25ths is equivalent. They're equivalent. They actually are equal. Okay, the last thing is simplifying algebraic equations. So what you need to do is write this out longhand. So you ask yourself, you first look at the numbers 12 and 15. And you kind of break it down. What can go into 12 and into 15? Well, I know 3 can. So 12 is going to be 3 times 4. And I picked 3 because 15 can also be divided by 3. 3 times 5. Okay, now let's go back up to the top. A squared means A times A. B to the 5th means B times B times B times B times B. And then C. Now underneath I had 15, okay, and then I have A squared, so that's times A times A. And then B squared, so there's B times B. And then times C squared. And now all I have to do is cancel, which is looking for 1s. So 3 over 3 is 1. That's what canceling is. You're dividing. You can only do this in a multiplication problem. So notice everything's being multiplied. A over A over A, B over B, B over B, C over C. And what you have left, on the top you have a 4 multiplied by B to the 3rd power, because there's 3 of them. And underneath, there's a 5 and a C. And that's it. All right, let's go a little quicker. The last one, 12 can be divided by 6, so 6 times 2 is 12. And then times x times x times x times x times x, because it's x to the 5th. Y times y times y. And then z times z. Underneath, 30 is 6 times 5. And then I have x times x times x times x times x times x. I need 6 of them, x to the 6th. There's a y, and then there's a z squared, which is z times z. Now I look for 1s. 6 over 6, x over x, x over x, x over x, x divided by x, x divided by x, y divided by y, z divided by z, z divided by z. Those are all 1s. What I'm left with is 2y squared over 5x. All right, that's it. Good luck.